All right, so today, and or whatever day you're looking at this video, I guess, we're going to talk about 11.5. So a new section. This is right after the quiz. There will be a practice with this as well, but bear with me. It's going to be a little bit of length here, just because there's a significant amount of content, all right? So fast forward at your own leisure or stop and pause the video as you need to. But today we're going to talk about angle sum theorems. So what I mean by that is, of course, the word angle. So we're going to talk about interior, exterior angles. We're going to look at polygons, right? And then we're going to look at, when you add those angles up and what degrees you get. And there are different patterns that you'll start to recognize depending upon the shape. All right, so diagram number 1, an interior angle. What we mean by that, okay, is if I draw you, for instance, a triangle, okay, an interior angle is any one of these three angles. And notice I'm using 3 different lines because we don't know that necessarily that those are congruent. So an interior angle, pretty simply, is an angle inside of a shape. Okay. Exterior angle, of course, then is an exterior angle, is the angle between any side of a shape and the line that is extended from the next side. So if I give you a diagram here, that'll make a little bit more sense. Say I give you the same triangle, okay? So the exterior angle is when you take basically a base or a side, extend it, and it is this angle, right? And so that is on the outside, just on the outside, okay? And again, when you take this line, extend it out, and that's on the outside. So those are what we call exterior angles. Okay, so if there are 3 sides, then we have 3 exterior angles, right? Just the same way that we have 3 interior angles. Okay, a polygon then, next vocab word, a polygon is any flat shape Oh, I meant to type in polygon right there. Polygon is any flat shape with n number of sides. Okay, so it could be a rectangle, could be a parallelogram, could be any shape, okay, with n number of sides. Basically, the word poly means multiple, so this is a polygon because it's got multiple sides. Okay, now a regular polygon is a very specific type of polygon. A regular polygon means, let me type this in. A regular polygon is when all angles are congruent and all sides are congruent. So all angles and all sides are congruent. Okay, so think of it like a rectangle. Okay, we know a rectangle has 90-degree sides, and it's also got four congruent sides. You could also think of it like a pentagon. Okay, pentagon's going to have all congruent angles and all congruent sides if it's regular. Okay, all right, so we're going to label the interior angles of the following polygons with letters of the alphabet and the exterior angles with numbers. So just making sure that you know what we're talking about. So interior angles with letters, well, that's these inside. Okay. And then exterior angles are, of course, to the outside. Notice I'm going all in the same direction. You could extend a line from here too, but notice how it crosses through mine, so you can only go in one direction when we're talking about these exterior angles. So in any one direction. Okay, so these are, for instance, 1, 2, 3, 4, 5, 6, 7, and 8. So this is an 8-sided shape. It's got 8 interior angles and 8 exterior angles as well. Okay, number 3, you could say that these are interior. And then we have our exterior. Again, all in the same direction. Okay, so those are your exteriors. All right, moving right along here. So we want to look at this chart here. We're going to start naming the type of polygon that it is, how many sides, right? How many sides it has, and we'll start looking at some patterns. So in this first one, of course, you know the name of this. It's called a triangle. Okay. Number of triangles in a polygon. Well, we know that this makes up one triangle. Now, what we mean by that is from edge, or vertex to vertex, I'm sorry. Or vertex to vertex. Okay, so what we mean by that is if I go to one point and draw a line to the other points, right, and then connect those, how many triangles does it make? Well, of course, it just makes one. Okay, what's the sum of all the interior angles? Well, what they're asking for is this, this, and this one. Well, we know that a triangle actually has 180 degrees in it. So the number of sides in a triangle is also 3. All right, so what is the measure of one interior angle of a regular polygon? Which means all the angles are the same, all the sides are the same. Well, you just take up the total divided by 3 because there were three angles, gives you 60 degrees. Okay, so 60 degrees in a regular triangle. All right, how about something that's four-sided shape? In fact, that's our last unit. It's called a quadrilateral. Okay, it's a four-sided shape. Okay, number 4. So four-sided shape. How many triangles can you do? So, okay, so if we go from a vertex, draw a line across, line across, line across to the other vertexes, it makes 2 triangles. Okay, so a triangle is 180 degrees. So 180 times 2 tells you that any quadrilateral is made up of 360 degrees. Okay, and then how do we measure the interior angle if they're all the same? Well, you just take up your total, which is 360, divided by the number of angles. This is 4. So this would be 90 degrees in a regular quadrilateral. Okay, how about this shape? This is called a pentagon, as we mentioned earlier. Okay, again, go from the vertex. First of all, pentagon has 5 sides. Second of all, let's talk about these triangles. So one vertex to the next, to the next, to the next, to the next. So we got 1, 2, 3 triangles. And 3 triangles, of course, add up to 540 degrees. So 540 divided by 1, 2, 3, 4, 5 angles gives you 108. Okay, so hopefully you're noticing the pattern here. Whatever shape it is as a polygon, divide it into that number of triangles, multiply by 180, and then divide by the number of sides. So sides, triangles, and then divide by the number of sides, as I mentioned. Okay, so number 6 is called a hexagon. Or I shouldn't say number 6, but this 6-sided shape is called a hexagon. 6 sides. Okay, you can make up 1, 2, 3, 4. 1, 2, 3, 4 triangles. 4 times 180, because there's 180 degrees in each triangle, gives you 720 degrees. Okay, and then 720 divided by the number of sides is 120 degrees. Okay, and then we continue on from there. So let's see here. This is called a heptagon or a septagon. 7 sides. Okay, 7 sides, and it makes up 1, 2, 3, 4, and 5, right? 1, 2, 3, 4, 5. Okay, so it's a 7-sided shape, is a hexagon or a heptagon. Makes up 5 triangles. 5 times 180 is 900 degrees. And again, 900 divided by the number of sides, in this case, gives you 128.6. Okay. All right. And then last one here is an octagon. It's got 8 sides. Right, 1, 2, 3, 4, 5, 6, 7 triangles. Okay. And wait, did I get 7? I'm sorry, 6 triangles. I was like, wait a second, that doesn't add up. 6 triangles. Math teacher, can't even count. Dear Lord. All right. And 6 times 180 is 1,080. So 1,080 divided by the number of sides, and that gives you 135 degrees for each of the interior angles. So that's how you can figure it out. If you don't know them off the top of your head, it'd probably be a lot faster just for you to do that. But again, personal preference. Take the number of sides, multiply it by the number of triangles you can make. Okay, so take the number of triangles you can make it, multiply that by 180. That gives you the sum, and then divide that by the number of sides. Okay. Note real quick, after an 8-sided polygon, there are no special names for the polygon, so we're just going to probably stick to 8 here in this case. Okay, we will probably won't go above that. But looking back at the chart, what is the relationship between the number of sides and the number of triangles for each polygon? Okay, so as you can see, look at the number of sides. You got 3 and the number of triangles. 3, 4, 2, 5, 3, 6, 4, 4, 5, 7, 5, and 8, 6. So what is the relationship between the number of sides and the number of triangles? No matter what polygon you got, it is going to be n minus 2, where n is the number of sides. Okay. Based on the pattern in the table, into how many triangles can a 17-gon be divided? Well, 17-gon is 17 sides, so that would be 17 minus 2, which is 15. 15 triangles. So therefore, what is the sum of a 17-sided figure? Well, it's 15 times 180, which, off the top of my head, I don't really know, so I plug in my calculator and I get 2,700 degrees, 2,700 degrees. So what is the formula to find the total degree of interior angles? It is n minus 2, so the number of sides of the shape. Subtract 2, that'll give you the number of triangles, and then multiply that number by 180 degrees. Okay, so if it's a 24-gon shape, 24 minus 2 is 22. So it would have 22 triangles. Multiply 22 triangles by 180 degrees. Okay, same thing here. So now it says, what would be the measure of one interior angle of a regular 17-gon? Well, if it's regular, then we know that each side has to be the same, and it adds up to 2,700 degrees, because that's what we just computed. But 17 sides means 17 angles. So you take the number of degrees divided by the total sides, right? And in this case, you would get 158 degrees. So let's think about that. We found the total degrees, and then we divided it by the number of sides. So it's basically to figure out how many for each individual, so any one angle, so just one, right? So we're talking like if it's a rectangle, we just want one interior, okay? You take exactly what we just did, take the number of sides, subtract 2, multiply it by 180, and then to find that one angle, you divide by the number of sides. So that is how you derive the formula for one interior and exterior angle. Okay, so that's it for day one. It's a little bit of a longer video, and I apologize for that, but we went through some definitions there. I'm going to cut the video here just to simplify it for you. There is a second day of notes, and I will go over that here in a new video, but I'm going to cut this one short. Go ahead and try the practice now if you want.